Hello viewers, moving on next question in this the next question is also 1 mark. The next debate question which have already given master question is what as follows. Instruments required to synchronize and alternated to the grid in or are. Options are given as A voltmeter, B wattmeter, C spectroscope and D stroboscope. So this is the theoretical question asked from synchronization of alternators. We all know that to synchronize an alternator to the grid, the parameter doesn't take the voltage. And other things are taken from the voltage. The other thing is really what basically it is a interconnection of a large number of alternators within it, and operating parallel. So for education voltage almost some margin, very small margin. Even it should be 0.5% of it. Even it should be almost equal. For maintaining same voltage magnitude, measure the voltage of the volt. Obviously not really by stepping it down and measuring various units. That was the voltage measurement. That was the voltage of stepping it down and then measuring the voltage. Voltage is required. Next, wattmeter is not required. Measuring active power. In this case, for synchronization, oscilloscope is required for measuring. The phases of the alternator with that of the grid. Income alternator with the grid. It synchronizes basically. Phase angle. Phase angle with the phase sequence. Otherwise, it doesn't make sense. So, the two are required and focus is not required. So, basically, to synchronize the alternator to the grid, the instruments required voltmeter and oscilloscope. Voltmeter for equalizing the voltage magnitude of the incoming alternator to the grid, and oscilloscope to synchronize the phase angle of the incoming alternator in the grid. So this is a very basic question from inversion of alternators. Based on some of the very basic concept. I hope the solution is clear. I have tried to explain the different aspects of inversion and what all instruments are different. So that's all for the solution. Thank you. Hello viewers, a very warm welcome back to the class. This time, public questions. So basically 6 questions came from the questions, you have 1 mark, you have 2 marks, total 9 marks of moderate level. So let's start this video with the solutions. Question number, starting with question number 26. 1 mark, master question for the question goes like the operating region of the cellular top the open induction motor drive in the figure. The load torque real characteristic is also shown. The motor drive moves from the initial operating point to the final operating point is. Which one of the following trajectory will take the shortest time? From the beginning, A, OQ, RF, OPA, COEF. Let's move to solutions question. The question was what? Regular torque versus the heat. Now let's encapsulate two basic fundamental relations for the induction based on speed and torque. So now P net torque is the developed torque and the load. And this is what accelerates the electric motor, this is the induction motor. J alpha mounted measure J, sorry, yeah, right, J, J, mounted measure J and alpha the angular is equal to the net torque. It is the difference of the torque, the developed torque and the load torque. We all know the fundamental relation. Using this variable to proceed and find which of the characteristics will take the shortest. Okay. Now let's proceed and check the options one by one. Okay. Hello. Yeah. So first topic, let's start with OQRs. Now for OQRs, this part T1 is less than, but not it is instantaneous change. So beyond this point, want to move on to OQ because the T1 okay, and that is so because the T1 given what? Momentum. As the becomes very large, on large for OQ box. You can see that the motor accelerates very fast. And the network is alpha ज़्यादा होता है. Alpha ज़्यादा होता है मोटर एक्टिव. That is to achieve this time taken calculation is higher for achieving speed or time taken is less. This is one of the possibilities. Let's put the other options as well. बाकी options OPS. OPS is order. Okay. OPS the difference is T1 OPS. Along this path, the torque is the speed right? OPS. Right? OQR QR. So for QR, what is this? Similar. So OP is the changes between speed increase. This is the PS. So no one is PS high, but less than option A. Not that. Less than E. This is the obviously less than E. As you can see, this is higher than this. So less than E. If you want to do I will not. So actually data omega in both the cases it is PS or only so the as you can see this difference later network and the expression I was not as one is OPS. And let's move to other options as well. OES. OES. Now OES will go to part of possible. Speed change happens now OE, part OE. Now for part OE, here even data from data. So T means less than negative. That is breaking or retarding. So the motor doesn't start at all. Showing it. Motor is open credit. This is an invalid. So now there is a question of even less than P. Breaking on the company. So motor will not start at all. Now let's learn OFS. Yeah. So mark. Now OFS people as now fitness and OE. Okay. Along FS for the BEF equal to right? You can put TE here into the term equal to out of TN. So there is no actually product. Then the angular acceleration. If the motor was is at constant speed, say initially it was at 0 speed, at a point there. The acceleration is what we do the same. That is omega. So move around the speed. Now the acceleration will be given 0. So this part is also not possible because speed cannot get OE and one part maybe contradiction. Right? There is no sliding torque, there is no angular acceleration, and the motor remains steady. But according to the graph, it is evaluated number. So option C and D did reasons, and among option A and B, as the information I had option A occurs the difference here, and the expression I had. So that so main thing OQR time taken for part A, that OQR should be greater. So let's say short. Right answer question is option A. That clearly explain the detail. from very basic. So, to talk, equation, all those things. To obtain that, the 32 equivalence is of 10. And to the highest equivalence. And the terminally operating expressions, equations of rotation motion. So I hope this question is clear. This may also work with comments. And that's all for doing this question. Hello, what's new learning? Next question is question 1 mark, 18 November 30. Question number 35. Of motors are connected. So the question is given as question is given as on application of a mechanical rope, the induced phasor, EMF phasor, reflected by an angular 2 degree mechanical load, mechanical with respect to the terminal voltage phasor. If the synchronous reactance is 2 ohm, and the theta resistance negative, another current negative dash. So let's move the solution for that. ठीक है ओके आसान है it is given the on the application of the load the induced EMF phasor जो given मतलब totally mechanical so motor will move back the load angle to drop okay mechanical okay now you can the number of we have a number of poles in the area. Now, this small epic, this model, the data is not own. So all load will be considered as initially a model. E here and the line to line. So small you can approximate that the magnitudes of the voltage are not changed. That is okay. Assume remain constant. Drop voltage is due to synchronous reactance. X is equal to 2 ohms. Right? So the voltage drop into drop at the terminal now as under the definition D and E are the equal of so this right? So we are here with the so basically some of the triangle is 180 degrees. It's clear. It is proper. So I we call it the E call it time to this is delta E minus delta E x. So I will what from the delta E is like what the complicated. It is all of plus it is also then I will identify the small variable magnitudes are still remaining same. You have to take it like I use this one mean this or yes this or right. From here what we make I use this taking detail and the values or values getting what sign related two sign delta or I what two business sign delta on two by okay both the values here if you remember the language of one three but delta okay delta one by one okay so you sign two you can if we find the answer, the answer will come out to be 56.5. Question. The temperature is not okay. And the question it is asked to round up this interface and noted from the founder a bit typical approach, not that generally not followed. Look at it, go through it, more clear. Cognitive and relative and by basic geometry relations were that using geometry of x triangle to obtain the
2 mod IA by mod ID by 1 by 2 by 3 and IAD lags I capital A by 30 degrees. So the right answer to the question is option A. I have explained it in detail. The first doing per phase MMF balance, then and using the relation for balanced delta connected system, then applying drawing the phasor diagram, finding the line current AD by using KCL as mode A, and to obtain that IAD mod IA by mod IAD by 1 by 2 and IAD lags IA by 30 degrees, which is for satisfies option A basically. So the correct answer to the question is option A. Hope the solution is clear and comprehensible. I explained the entire thing, entire concept in detail. If you still need doubts or queries, please feel free to ask me comments. And that's all for solution to this question from transformer connection. Thank you. Hello viewers, moving on to the next question. This is K225 electrical engineering solutions from subject electric machines. In this video, we will covering the details video solution to the question of 44 of 2 marks MCQ type that have been the master in K225 electrical engineering. Question number 45 and the master question paper of K225 electrical engineering from subject electric machines is from DC series motor and is as follows. A DC series motor with negligible series resistance is running at a certain speed, driving a load where the load torque varies as cube of the speed. The motor is fed from a 400 volt DC source and draws 40 amperes armature current. Assume linear magnetic circuit. The external resistance that must be connected in series with the armature to reduce the speed of the motor to half is closest to. Options are given as A 23.28, B 44.82, C 46.7, and D 0. Let's move to the solution to this question. So basically DC series motor with linear magnetic circuit. What do we have? Phi is proportional to armature current IA. Right, for linear magnetic circuit for DC series motor. Okay, is given as the negligible series resistance, that is RA is negligible to 0. So initially it is terminal voltage is given as the DC voltage given, and initially as there is negligible internal resistance called armature resistance, the EMF, induced EMF or the back EMF is also 100 volts at no voltage. Right. Okay. Right. Let's say the mode of speed was n or something. Let's say n. Okay. Now we have to reduce the speed to n by 2, it's to half. For the DC series motor, it is given the load torque TL varies as cube of the current, that is IEQ. We already know that load torque is, or the electromagnetic torque is proportional to phi into IA. As phi is proportional to IA for linear magnetic circuit, so electromagnetic torque is proportional to IA square. Now for the steady operating conditions, TL, the load torque should be equal to the developed torque, that is motor developed torque TEM. So basically what? Sorry, given cube speed also. Cube. For steady operating conditions, what we have? TL equal to TM, the load torque should be equal to electromagnetic torque, so the motor behaves, operates steadily. So if we equate these two conditions, then we get that the speed cube should be proportional to IA square. Or in other words, IA should be proportional to n to the power 3 by 2 or 1.5. Right? To reduce the speed to half, IA should reduce to n prime equal to n by 2. Say IA prime should be equal to n by 2 to the power 3 by 2. Right? So n by into IA. Yeah, so basically IA prime equal to n by 2 times, it is n by 2, sorry, not n by 2, n by n, that is half. Sorry, psi is proportional to n to the power 3 by 2. So IA prime by IA should be equal to n prime by n to the power 3 by 2. Now n prime equal to n by 2. So we have n by 2 by 2n, that is 3 by 2, that is half to the power 3 by 2. Or obligate IA prime equal to IA by 2 root 2. ओके, ठीक है। I by 2 root 2, so I prime will be what? 40 by 2 root 2, that is 10 root 2 amperes. Right? Also, we have back EMF is proportional to phi into n. We know set it here. Back EMF is proportional to phi into n. ठीक है? For the series linear magnetic circuit, we have phi is proportional to IA, so it is proportional to IA into n. Now IA is proportional to n to the power 3 by 2. Got it from here. So this is proportional to n to the power 5 by 2. Okay. Now n becomes half. EB becomes what? EB prime equal to EB into half to the power 5 by 2. That is EB by 4 root 2. Right? Right. So the putting the value of EB initially, it is from EB no load, is 400 volts. So finally it becomes 400 by root 2, 4 root 2, that is 50 root 2. Okay. So we can find the current as EB prime equal to V. Timing voltage remains unchanged, minus IA prime times RA external. RA is 0, but there is some RA external. RA external that needs to be applied, inserted, connected in series. So EB prime, if you put 50 root 2 equal to 400 minus IA prime. IA prime is what? We found in this case. IA prime will be what? Yeah, for 10 root 2. So 10 root 2 times R external. From this, here we can find R external as for 400 minus 50 root 2 of what? 10 root 2. So we get this as 20 root 2 minus 5. So if you put the values, we get 20 root 2 minus 5 as nearly equal to 23.28 ohms. So this is option A. So by using the basic relations for this DC series motor and linear magnetic circuit, I have first derived the relation between torque and the speed and armature current. Using that, we reduce the speed to half, the corresponding armature current has been found, and then from that, using the back EMF relation, the corresponding back EMF, and hence the external resistance that has been connected in series the armature to reduce the motor speed to half has also been found closest to 23.28 is option A. Our solution is clear and comprehensible. If doubts or queries for this simple solution, please feel free to ask in comments. And that's all for this question. Thank you.
Hello viewers, moving on to the next question in this series of electric machine. In this video, I will be giving you the detailed video solution of question number 45. Is it to what asked from the subject electric machines. Okay. So let's start the solution. Let's first look at the question. It is given a 3-phase 400 volt 4-pole 50 Hz star connected induction motor. There's the following parameters referred to the stator. RR time, that is the rotor resistance referred to the stator, is 1 ohm, XS is equal to XR time 2 ohm. Stator resistance, magnetic reactance, core loss of the motor are neglected. The motor is run with constant V by F control from a drive. For maximum starting torque, voltage and frequency output respectively from the drive is closest to. Options are given as 400 volt and 50 Hz, B 200 volt and 25 Hz, C 100 volt and 12.5 Hz, D 300 volt and 37.5 Hz. As you can see, let's move on to solution for this. Pretty simple, basic concept. Basic concept of basically V by F control. V by F speed control. So we all know the maximum torque occurs at a slip which is given by R prime S T XS plus plug in the values of put the values we get right. Simply composing so the maximum torque is obtained at a slip of 0.27 or 25%. Speed flow characteristic right. Okay. Now to obtain the maximum starting torque, obtain the maximum torque to obtain this at right at the starting, what do we need to do? We need to increase the signal speed. Signal speed is by okay. 2.2 right. to decrease the to obtain the maximum profit starting at starting the membership is right. One minus three, one minus one point correct. To increase the supply frequency of the and thereby decrease the synchronous speed. Then for sheet weight. Sheet parallel to the original curve. Right. This is also we are reducing the synchronous speed with what SMB times the shift. So this synchronous speed will what? One minus similarly, at this point, one minus SM. So, it is given as 50 here. Then it is 50 years. 50 times 1 minus SM is 0.25. So, we by doing this, we get the moderate frequency of the drive needs to supply for motor control. Control method is times corresponding to statistical fibers. Originally, it was what 400 or what 400. 400. Now let's say the supply voltage from output from the drive is V prime. Let's say the corresponding voltage supply from the drive is V prime. Very good. V prime is what 400 by 50 times. Okay. To cross multiply, right? So get how much? Yeah. Fair. So the maximum starting torque, maximum torque starting the voltage and frequency output from the drive should be equal to 300 volts and 25 volts. The right answer to the question is option B. To solve the question very simply using the basic concept of peak torque curves and the inverse control method for inverse induction. And by doing some complete with the maximum torque, we found the moderate right from maximum starting torque, and by maintaining P by a constant, we found the term of the voltage. So I hope this is clear, comprehensible. That's why it's very basic. Also explain the basic concept behind the approach to solution. Hope the solution is clear and comprehensible. If you have explained doubtful queries, any of the steps that I followed in obtaining or reaching the answer, please feel free to ask in the comments, and I will be glad to help by and resolve your doubt by answer. That's all for the solution. This question. Thank you.